students, this is the third video in the series. We're looking at the Unit 3 Inequalities, Lesson 5 review. We're trying to get ready for that quiz that's coming up. We've already done the do now, and we've already done interpreting solutions to inequalities. Now let's transition to solving inequalities. Hopefully you already did these, but if not, pause the video, try that first one, and then come back to see if you got it right. By now, you know that you're solving equations and inequalities in the same exact way. So I'm going to add 10 to both sides. I'm using my inverse operations. I got 2x is less than 22. Last but not least, I do need to divide in order to get x by itself, but I'm dividing by positive 2, so I don't have to change the sign or the direction of the inequality. I have my inequality solved as x is less than 11. It asks for the largest integer that satisfies the inequality, and an integer, remember, is a positive or negative number with no decimal part. So I'm looking for the largest number, non-decimal number that satisfies this. Well, if x is less than 11, the next integer down is 10. Moving on to the next one, it says name the smallest integer that satisfies the inequality. Let's solve the inequality first. You already did that. If not, pause the video, try it out, and then see if you got it right. Our first step here is to add 21 to both sides, get rid of that 21. That negative 21, I should say, and then I have negative 4x is less than or equal to 24. Now I'm going to divide both sides by negative 4. And you know what happens when you divide by a negative? Flip that inequality. So I know that x is greater than or equal to negative 6. If I'm looking for the smallest integer, positive or negative number with no decimal part, then I can use negative 5, negative 4, negative 3, but the smallest of them is going to be negative 6. And the reason I'm allowed to use negative 6 is because this inequality has that equal sign underneath it, which means I can use this value. So my smallest integer is negative 6. Try that third one. Again, pause the video, try this one out, and then see if you get it right. First step, inverse operations. Subtract 8 from both sides. I get negative x is greater than or equal to 10. I'm going to divide by negative 1 to get that x by itself, which means I flip that inequality. Know that x is less than or equal to negative 10. Well, it could be negative 11, negative 12, negative 13, but the largest integer is negative 10 because I have that equal sign. So my largest integer is negative 10. Last but not least, name the smallest integer that satisfies this inequality. Looks like some distribution property is going to go here in that left-hand side. Pause the video, try it out, then come back to see if you got it right. We distributed first, 4 times negative 3, negative 12, 4 times x, 4x. Now we're going to move that negative 12 to the other side using inverse operations. 12, which is the inverse of negative 12, is going to give me 4x on the left-hand side and negative 28 on the right-hand side. Now I'm going to divide both sides by 4. I'm not dividing by a negative here, I'm dividing by a positive, so I don't have to flip my inequality sign. This says x is greater than negative 7. So we're looking for the smallest integer that satisfies this inequality. Well, anything that's greater than negative 7 would satisfy it, but the smallest integer that'll do that is negative 6. Why not negative 7? No equal sign. The next largest integer, the one that's larger than negative 7, is negative 6. So there's our answer. Right, this was the video on solving inequalities. Again, we were looking at the review of inequalities, which is lesson 5 in unit 3. Good luck studying.